welcome back. So in our previous segment, we talked about what nuclear fusion and nuclear fission were. So in this segment, we're going to show how does a nuclear physicist show how various elements combine and turn into another element. Incidentally, this was the goal of people back in the Middle Ages. So if you recall, there was a science that was called alchemy, and their ultimate goal was to be able to take lead and then turn it into gold. But they never could do it because they kept trying to use chemistry in order to do that. And so you can, however, change elements by smashing them together or by pulling them apart through nuclear fusion and nuclear fission. So here's an example of how that's done, and this does require you to be able to add and subtract numbers. So for example, let's look at this nuclear fusion example. We're starting off with a particular isotope of hydrogen, so this would be hydrogen 2. We don't really need to write down that 1 underneath it, underneath the 2, because every hydrogen has an atomic number of 1. But for this purposes, it is useful to put that 1 underneath the 2. And we're going to smash it into helium 2, and we want to know, what does it turn into? Well, obviously you can see it turns into lithium, but let's assume that we don't know that. So what we're going to do is we're going to add 2 plus 2 makes 4. Okay, so we put the 4 up there at the top, and then 1 plus 2 makes 3. So we put the 3 underneath the 4. And now we got to figure out, well, what element is that? So we get out our periodic table, and we have a choice. We could either look up the 4, or we could look up the 3. So which one would we want to do? We're going to look up the 3 because the atomic number, the 3, determines the identity of the element. The upper number could be different because they would be different isotopes. So we would need to use that number 3. We look it up on the periodic table, the atomic number, and that turns out to be lithium. Okay, let's look at the second example there. We're going to start out with uranium-236, and it's going to turn into, so that's what the arrow means, yields, krypton-84 plus what else? Now we know that the answer is going to turn out to be barium, but how did we get that number? So this time, think of that arrow as being an equal sign. So if I had said to you 236 equals 84 plus what, you should be able to do that because you just subtract the 84 from the 236 and you get 152. Likewise, if you take 92 and you subtract 36 from it, you get 56. So that's how we got the 152 and the 56, and then we're going to look that up on the periodic table. Which number? We're going to look up the 56, and then that's going to turn out to be barium. So we put down Ba. So if I was going to give this to you on an exam, it would look like this. So we're going to take lithium-6 and we're going to smash it into beryllium-7, and we want to know, what does it turn into? So you have to fill in the question marks. So we're going to think of the arrow as being an equal sign, and we're going to take 6 plus 7 equals 13, and we're going to take 3 plus 4 equals 7, and now we need to get out our periodic table, and we're going to look up the number 7, and that's going to be nitrogen, so we're going to put down an N for nitrogen. Okay, and let's try this one. So solve this nuclear reaction. We're going to start off with plutonium-244, and it's going to turn into copper-64 plus what else? So this time we're going to have to subtract the numbers. So we're going to take 244 minus 64, and we're going to take 94 minus 29. Okay, so now we got those two numbers. And then which one do we look up on our periodic table? Okay, that's going to be the 65. And so that turns out to be Tb, which is terbium. Okay, so I would, on the exam, I would give you the periodic table, but you've got to know how to read it in order to be able to solve these kinds of equations. All right, now we're going to take a break, and when we come back, we're going to talk about how is energy generated in either a nuclear fission reaction or a nuclear fusion reaction. So we'll see you in just a moment.